right. I'm still in 5.1, trying to teach you about antiderivatives. I wrote down some of the trig rules here. Well, I didn't finish all of them. So you remember there is six trig functions, and we learned their derivative rules back in chapter 3. So here they are backwards. If you remember, the derivative of sine was cosine. So what is the antiderivative of cosine? It is sine plus c, sine of x plus c. So the integral of cosine. So you're doing those rules backwards. Do you re-memorize them? I don't know. If you had those derivative rules memorized, you just got to think about them backwards now. What's the derivative of the sine x? It is negative cosine x. Why is that? The antiderivative. What was the derivative of cosine? Back in the day, the derivative of cosine was negative sine. So if I'm integrating a sine, I get a negative cosine. Wow, plus c. Secant squared is easy. He's a famous derivative. Secant squared is a famous derivative of somebody. The derivative of tangent was secant squared, so what's the integration of secant squared? A tangent function, plus c, tangent of x plus c. Secant x tangent x was somebody's famous derivative. That was secant x plus c. Cosecant squared was negative cotangent x plus c. And the antiderivative of cosecant cotangent is negative cosecant x plus c. We learned these derivative rules going this way, and here's the new rules going backwards. So these are easy. What's not here is what is the integral of secant x? And actually, this chapter, much later, we'll learn that. But right now, secant x was never anybody's derivative. Secant x was not a famous derivative that we knew. Secant x is a famous function, but he wasn't the result of anybody's derivative. Therefore, I cannot do his antiderivative. Not until I get a little creative, maybe later. What about like a cosine squared? Right. The power rule doesn't really work on cosine squared was not a famous derivative of anybody. So this is not an antiderivative I can just shout out. I can do secant squared. It's tangent because the derivative of tangent was secant squared. So the antiderivative of secant squared. So I can do these famous ones. This is not famous. I have to do a lot of manipulating and learning. That comes later. So there's a lot of things, if I just throw up some integration here, you can't do. You can only do kind of these ones that fit these forms that we've learned so far. As we progress through this chapter and through Cal 2, we learn a lot of integration techniques that help us out. So let's try something else here. I'm getting rid of these rules. There's a couple other rules for you. I had those down the other day. The integral of e to the x is e to the x. The integral of 1 over x dx is the natural log of x. That about covers it. I've got all our trig rules. We got those. Later this chapter, we might do the inverse trig rules. We'll get there. But what about something like this now? Back to our, what about t squared plus 1 squared with respect to t? So I'm just doing this one with a variable t. But this is nowhere in our rules, The only thing I have in my rules is a power rule. And so I've got to, what your book suggests, and I suggest, is that we rewrite this. You got to do some algebra before you can integrate. So you FOIL this out. You do some algebra, you FOIL this out. Your book calls that rewriting the integrand. We call that the integrand. You rewrite the integral or the integrand. You FOIL it out. If I FOIL it out, that's t to the 4th plus 2t squared plus 1. And now I can integrate it. Now it's a nice polynomial I can integrate. Just to finish it, 1/5 t to the 5th, 2/3 t cubed. You guys with me? Little power rules, plus a t plus a c. I just integrated that. Let's try another one. What about the cube root of x times x plus 4? You know, I told you there is no such thing as a product rule, and some students fall into a trap of thinking they can just integrate a product. You can't integrate a product. So I'm sort of stuck here. What I need to do is distribute, kind of like I did that. That was foiling. I need to distribute and then integrate. I need to rewrite this integral. So in order to do that, I should think of it as x to the 1/3 multiplied by this x plus 4. Okay, I gotta distribute and then integrate. Let's see here. Rewriting the integral, x to the 1/3 times x. You add those powers. I think that's x to the 4/3. Because I'm adding a 1. Yeah. And then I got a 4x to the 1/3. And I distributed the x to the 1/3. And now I have two separate terms. Now I can integrate. Here we go. How do you add 1 to the power? X to the 7/3. When you add 1 to that, that's adding a 1. Divide by 7/3. I like to say multiply by 3/7. Good, he's finished. Plus, let's integrate him. Add 1 to that. X to the 4/3. When you add 1 to that, multiply by 3/4. I mean, divide by 4/3, but that means multiply by 3/4. Multiply by 3/4. That'll cancel that 4. That's that. Plus c. These are good examples. Let's do another one. Let's do this guy. X squared plus 5 over x cubed. So again, I told you once, there is no such thing as a quotient rule. There is no quotient rule. I've got to try to make this a power rule. That's about all I got. Besides the trig rules, and I've got a power rule, you know. So I probably should divide this guy separately into these two terms. Yeah, that's what I should do. Or some people say, move it up, call it an x to the -3 and distribute it. Or divide it separately. There's a couple ways to think through your algebra, but you have to rewrite the integral. Let's see, what is an x squared divided by an x cubed? Oh, that's going to be a 1 over x, actually. And then a 5 over x cubed. That'll be, I'm going to write that as 5x to the -3. So I divided the x cubed into each one of those. I guess I could have called this x to the -1, but I'd rather write it like that because that reminds me of a rule. I know what that is. The integration of him is not a power rule. A 1 over x is a natural log of x. So here I go. The answer to that one is the natural log of x. And the answer to this one is a little power rule. I'm doing two separate integrals. I did that integral. Now I'm doing that integral. What do? You add 1 to the power, x to the -2. Divide by -2. When you divide by -2, you could call that a -5 over 2. Plus c. I'm pretty happy with that. I guess you could drop that x squared back into the denominator, you know, to technically be right. Yeah, these are good. Good examples. 5.1, there's more to say. There's more to say about velocity and acceleration and position functions. But good luck.